Welcome to this intro on polynomials. Our first term we're going to talk about is called a monomial. Now, a monomial is a number or a product of numbers and variables with whole number exponents. For example, you might see 6x to the third power. That's a monomial. Or you might see 4x squared y to the third. This is a monomial as well. There's no addition or subtraction signs separating it. This, however, is not an example. 8x to the 1/2, because this 1/2 is not a whole number, so it's not a monomial. Polynomial is a monomial or a sum or difference of monomials. So in our previous example, you saw this as a monomial. It can also be referred to as a polynomial. Here's where we have two polynomials separated by addition. So again, it can be more than one monomial being separated by a sum or a difference, so addition or subtraction. Not polynomials would have maybe variables as exponents, fractions with the exponent in the bottom of the in the denominator, having exponents in the denominator. A degree of a monomial is the sum of the exponents of the variable. So for example, if we were looking at the degree of these monomials here, the first one is x to the 4th, so it has a degree of 4. 12, that's a monomial. It has no exponents, so its degree would be 0. 4a to the 2nd, b to the 1st. We never usually write this, but this degree would be 3 because it is a sum of the exponents of the variables. There are two variables. A has a power of 2, b has a power of 1. 2 plus 1 is 3. Our last example, x to the 3rd, y to the 4th, z to the 1st. 3 plus 4 is 7 plus 1. This monomial has a degree of 8. The degree of a polynomial is different. We like to write polynomials in standard form, meaning highest degree down to the lowest degree. The leading coefficient means the term that starts the polynomial. So it is the coefficient, the number in front of the variable that starts the polynomial. The degree is the highest degree of the term. So this polynomial, the degree would be 3. It is a cubic function. This table can be seen in your book. It describes the different degrees of polynomials and their names. So if we have a degree of 4, it is a quartic, or degree 5, it is a quintic. Linear, quadratic, and cubic you've definitely seen before, but a quartic and a quintic would be something new. Classifying polynomials. So it says rewrite each polynomial in standard form, identify the leading coefficient, the degree, and number of terms. Standard form means we write it from highest degree to lowest degree. In A, my highest degree would be 4x to the 3rd plus 2x minus 1. This would be my standard form. Now we need to identify the leading coefficient, LC. Well, that's the number that is in front of the variable with the highest degree. So the leading coefficient here would be 4. The degree would be 3. The number of terms would be 3. And it says to name the polynomial, it has a degree of 3, So we could look at the chart. Degree of 3 is a cubic. So that's how we would name it. Let's try example 2 here. Start with standard form. We're going to choose x to the 5th. We have plus 7x cubed minus 11x minus 2. Remember to always keep the sign that's in front of the monomial. So leading coefficient here is 1, degree 5, number of terms 4, and it is a degree of 5 quintic. I'm going to skip those. Adding or subtracting polynomials. To add, all you need to do is combine like terms. Write it in standard form, so when we start to combine like terms, we look for the highest power. Highest power here would be 14x to the 3rd power. Nothing to combine it with, so we're done with our powers of 3. Let's go on to powers of 2. We've got 3x squared plus x squared. That would be positive 4x squared. We're done with those. Now we look for just our x's. That's positive x minus x. It's going to go away. 1 minus 1 is 0. And our last terms would be 7, 2. That would be 9. Adding is pretty straightforward. Subtracting, though, we have one step to do before we start to subtract. And that is we need to distribute the negative to all 3 terms before we combine. So I'm going to start by rewriting the first term, 1 minus x squared. And then all we really need to do is change the sign of these 3 terms, because we're going to distribute the negative. So it becomes minus 3x squared minus 2x plus 5. Then just go to your combining your like terms. So negative x minus 3x squared, negative x squared minus 3x squared is negative 4x squared. So you're done with those. Then comes minus 2x. Then we have 1 plus 5 gives us a plus 6. So to subtract polynomials, you just have to distribute the negative. Last thing, you'll need your calculator for this. You'll need to type in that function in order to graph it on the calculator, and you're going to identify the number of real zeros. So I don't have a picture for you, but I'm going to do my best to draw a picture of this graph. So if you had your axis, I'm going to change this to black. Let's say we had, here's our axis. Here's a rough sketch of the graph. Okay, comes up here, comes through the middle, and back up. So on your calculator, if you graphed it, it would look something like this. Or if we wanted to identify the number of real zeros, if you remember from previous lessons we've done, that is how many times it crosses the x-axis. Well, it crosses it here, here, and here. So it crosses the x-axis 3 times, therefore it has 3 zeros. On your assignment, when you get to these problems, I want you to make a rough sketch like I have made right here, and then tell me how many zeros it has. You do not have to describe the graph.